Hello and welcome to my today's lecture on Fundamentals of Information Theory. I am Dr. Orikit Shah, Associate Professor of VP Poddar Institute of Management and Technology, Kolkata, India. Today we will try to cover some fundamental topics, that is Introduction to Information Theory, what is self-information, what is conditional self-information, mutual information, average mutual information, and a brief idea on entropy. Now let us start with some fundamentals to information theory. Now Claude Shannon developed a completely new theory of communication in 1948, and he called it a mathematical theory of communication. There he established the basic theoretical bounds on the performances of communication systems. Basically, information theory deals with three concepts. The first one, the measure of source information. What is that? It is the rate at which the source generates the information. Secondly, the information capacity of a channel. What is it? It is the maximum rate at which reliable transmission of information is possible over a given channel with an arbitrary small error. Finally, the coding. It's a scheme for efficient utilization of the channel capacity for the transfer of information. Let us think of a simple communication system with source and channel. Now we can see from the picture that there is a source encoder where the source information is coming. Then it is going to a channel encoder where the channel coding is being done. It is then passed on to a noisy channel where the noise can be added up. Then there will be a channel decoder to decode back the original source information. Finally, there will be a source decoder and then it will go to the destination. So the channel encoder decoder basically performs the task of error control coding. An optimum channel coding yields an equivalent noiseless channel with a well-defined capacity of information transmission. And the source encoder decoder is then used to match the source to the equivalent noiseless channel, provided that the source information rate falls within the channel capacity. Now what is an information source? It is an object that produces an event, the outcome of which is selected at random according to a probability distribution. It can be anything, like I am talking, this is an information. The information is sent via the channel to you are listening, so you are the receiver. So now it can be classified as having memory and memoryless. Now when current symbol depends on the previous symbol, it is said to be consisting of memory, and each symbol is being produced independently of the previous symbol. If that is the case, then it will become a memoryless system. What is a discrete memoryless source, or DMS? Now each message emitted is independent of the previous message. When such a source sends a number of independent messages like M1, M2 up to MM with their probabilities of occurrence P1, P2 up to PM respectively, then the messages are correctly received. The information measured in the composite message is given by, the information is log base 2 1 by P1 plus log base 2 1 by P2 plus, like this we will go on adding up all the probabilities, and finally the information is coming out to be I1 plus I2 plus IM. Now we have to keep in mind that since they are all probability distributions, so all the probabilities will sum up ultimately to 1. We are talking a lot about information. Now what is information? Now any information source, it might be analog or digital, produces messages or events, the outcome of which is selected at random according to a probability distribution. So a message containing knowledge of low probability of occurrence conveys more information than one with a high probability of occurrence. And we can say information is inversely related to the probability of occurrence or directly related to the uncertainty. For example, when we are saying sun rises in the east, it basically has no new information because the probability of occurrence is 1. So in that case, by the definition of information, it becomes 0, the information. Whereas if we say a dog bites the man, it has information but very less amount because it's a very probable event. Although the probability is not 1, but still it's a high probable event. So the information content is less. If we say now a man bites a dog, then the probability is almost nil. In that case, the information content is very high. So we can understand that information is basically related to the inverse of the probability of occurrence. What is information rate? If a source generates R messages per second, the rate of information or the average information per second is defined as capital R equal to capital H by T equal to RH bits per second. Here T is the time required to send a single message. So what should be the unit of information? Although the probability is a dimensionless quantity, a unit is assigned to information I. The unit of I is the bit or binary unit different from binary digit if b equal to 2. When the base is e, the unit is nat, that is natural unit. For b equal to 10, the decit or Hartley unit is used. When no base is mentioned, the unit of information is taken to be as bit, that is by default b will be taken as 2. The information given in one unit may be expressed in other unit by the following relationship: log a base 2 equal to log a natural base by log 2 natural base equal to log a base 10 by log a base 2. So we can see that interchangeability between the different relationships is possible for information. What is self-information? Now, let a digital source generate a message M having a probability of occurrence P. The measure of information was quantitatively defined by Shannon as I equal to log 1 by P base B, that is minus log P base B, where I is the self-information of the message M and B is the logarithmic base. So, P, since we know it lies between 0 and 1, so I should always be greater than 0. That is, information is non-negative. The amount of information in a message depends only on its probability of occurrence rather than its actual content or physical interpretations. Now we come to mutual information. A communication channel has an input X and an output Y. The state of knowledge about a transmitted symbol Xj at the receiver before observing the output is the probability that Xj would be selected for transmission. This is a priori probability P of Xj. The corresponding uncertainty now becomes minus log P of Xj. After Yk is received at the output, the state of knowledge about Xj is the conditional probability P Xj provided Yk received, also known as posteriori probability. Corresponding uncertainty now becomes minus log T Xj probability of occurrence corresponding Yk is received. The information I Xj Yk gathered about Xj after the reception of Yk is a net reduction in the uncertainty, that is I Xj Yk equal to initial uncertainty minus final uncertainty. So finally, the relationship shows that I Xj Yk is similar to I Yk Xj. Today we will try to cover some fundamental topics, that is introduction to information theory, what is self-information, what is conditional self-information, mutual information, average mutual information, and a brief idea on entropy. What is conditional self-information? Now, conditional self-information of an event x equal to xj, given that y equal to yk is defined as I of xj by yk equal to log 1 by p xj by yk equal to minus log p xj by yk. Now, since the mutual information I xj yk equal to log p xj by yk by p xj, hence the information I xj yk becomes I xj minus I xj by yk, can be interpreted as self-information about the event x equal to xj having observed the event y equal to yk. What is self-information? Now, let a digital source generate a message m having a probability of occurrence p. The measure of information was quantitatively defined by Shannon as I equal to log 1 by p base b, that is minus log p base b, where I is the self-information of the message m and b is the logarithmic base. So, p, since we know it lies between 0 and 1, so I should always be greater than 0. That is, information is non-negative. The amount of information in a message depends only on its probability of occurrence. Now we want to define entropy. It is the average information per individual message emitted by a source. However, the term average information is used to indicate statistical average and not arithmetic average. Let us consider m number of different messages m1, m2 up to mm having their respective probabilities of occurrence p1, p2 up to pm. The source generates a sequence of L independent messages over a long period of time such that L should be much greater than M. The number of messages M1 within L messages is P1M, and the amount of information in each message M1 is log 1 by P1. The total amount of information in all M1 messages is P1L log 1 by P1. Thus, the total amount of information in all L messages coming out as I total equal to P1L log 1 by P1 plus P2L log 1 by P2. Like this, we go on adding up to mth, that is PML log 1 by PM. So the average information per message or entropy will be H equal to IT by L equal to P1 log 1 by P1 plus P2 log 1 by P2 up to PM log 1 by PM. Hence, the average information per message or entropy will be summation over j equal to 1 to m pj log 1 by pj equal to minus summation over j equal to 1 to m pj log pj reached percentage. If m equal to 1, that is there is only a single possible message, and pj equal to p equal to 1, then under such situation the message carries no information and h becomes 1 log 1 by 1, that is equal to 0. With that, we come to the end of this presentation. Thank you for your patience.